Today we are looking at factoring trinomials, and the trinomials we're doing today will have a leading coefficient of 1. All of them will have a leading coefficient of 1. That will keep it simple. When we factor a trinomial, we're actually moving from trinomial to two binomial factors. If you remember back from previous sections, we multiplied two binomials to get a trinomial. Now when we factor, we're moving backwards to factors of binomials. So let's do this first one and look and see how it's going to work. First thing you do, since we're doing two binomial factors, we're going to have two parentheses, hopefully better looking than that. And because there are two plus signs here, we're going to put plus signs there. Okay, it works out like that. It's pretty good. So for the first term in each binomial, we're going to basically put an x here and an x here because x times x is x squared. For the last term, we got to think a little bit. So I'm going to look at this. I need things that multiply to be 12. Well, 1 and 12, right? 2 and 6, and then 4 and 3. Okay, but out of these pairs, I need a pair that adds to be 7. And that takes care of that one and that one. It's only this one that will work. And it doesn't matter which one you do first, the 4 or the 3. But that's our factors. That's our binomial factor right there, x plus 4 and x plus 3. Okay, good. Let's move on to the next one. Let's clear this out just a little bit. Okay, I'll just keep this for the next one. I've got x and x here and here. I got plus signs. Then here I've got a 9 and 2, and 18 and 1, and 6 and 3. Well, 9 and 2 make 11, so I'm going to use 9 and 2, and we are finished with that. Okay, let's look at the next section, or the next two. Okay, there are my parentheses. Looking at this one, I've got x here and x here. You'll notice all of these that we're doing today will have x's there. We got plus signs. That will change up in the next example. Here I have a 5. Well, the only thing that multiplies to be 5 is 5 and 1. And we notice that 5 plus 1 is 6, so that indeed works. 5 and 1. Those are binomial factors. Okay, now if we back up a little bit and we get this one here, we've got y's instead of x's. Put a y here, y here. I'm looking at 24, okay, so I know that 6 times 4 is 24, but that doesn't give me 11. I know that 12 times 2 is 24. That doesn't give me 11. I do know that 8 times 3 is 24, and 8 plus 3 gives me 11. So my factors are y plus 8 and y plus 3. And again, it doesn't matter which one is where the 8 and 3 go here. Okay, moving on to the next group. Let's see if we can move down just a little bit. I think we're on the third group right here. Good. Okay, parentheses, parentheses, plus signs. I've got x and x for this one. Now, I've got 15, which is 5 times 3. That's what comes to mind first, and 5 plus 3 is 8, so that works. And that is finished. Okay, back up. I'm going to keep the x's here. I'm looking at 6. Well, that's 2 and 3 and 6 and 1, but the only pair that gives me 7 is 6 and 1. So I've got a 6 here and a 1 there. Okay, next two, or the last two in this example set. I've got an x and an x here, plus sign, plus sign. Now let's look at 28. Well, that is 7 times 4, 14 times 2. Okay, so if we are 28 and 1, 7 and 4 actually added together give me 11. So I'm going to use 7 and 4 for my factors. Let's back up and let's do the next one. And since that's z, we're going to back all the way up. Okay, we've got a z here, a z here, plus sign, plus sign. 20, well, that is going to be, looking at this, that's a pretty big number. We're going to have to use 20 and 1. 2 times 10 is 20, 5 times 4 is 20. 20 and 1 are going to give me 21 when added together. So 20 and 1, again, doesn't matter. And those are the factors that we get from z squared plus 21z plus 20. So in all of these, if you'll notice, we have both this term and this term are positive, and the first term. They're all positive. Everything's positive. When that happens, when we have a trinomial where every term is positive, well, we have two plus signs in our factors. Okay? That takes care of example 1. In example 2, notice we still have a trinomial. Notice the leading coefficient is still 1, but the only difference here is that the second coefficient is the coefficient of x is negative. Okay, the constant is still positive. The first term is still positive, but the only thing negative is this middle term, or that leading coefficient of x. So that's not going to change how we do things a whole lot. It's just going to change what it looks like a little bit. So we'll go through these pretty quickly because we've already completed some problems that are like this. So we've got an x here and an x here. Okay, now with a minus and a plus, you're actually going to get two negatives. That negative positive pattern in a trinomial, when you factor, you get two negatives. So it's just like when you're figuring it out, it's just like having two plus signs or two addition signs. Okay, so we got two minus signs with a negative positive pattern here, and we're looking at factors of 8 that add to be 6. Well, that is going to be 2 and 4. Okay, 2 and 4. So when we put those in there, -2 and -4 give me -6. And then -2 times -4 give me +8. So this indeed works out. Okay, let's back it up for the next one, and those are z's. I had to change that. Don't know why. Okay, so we're going to put a z here, a z here. We've got a minus sign, plus sign, or subtraction addition sign. So we're going to do two subtraction signs because of that pattern. Now I'm going to look at multiples of 40, or things that multiply to be 42. Factors of 42, 6 and 7 multiply together. And I think if we add those together, we get 13. So I'll put a 6 here and a 7 here. Okay? So notice the middle term, just to show you, the middle term we get by multiplying the outsides and the insides and adding them together. So -7z and -6z give me -13z for my middle term. The first term we get z squared by multiplying those. The last term we multiply these to get +42. So that works. Okay, next two. We'll go with y here and y here. Well, 20, things that multiply to be 20 are 5 and 4. That's the first thing that comes to mind, and it actually works. We got a 9 here. A subtraction addition pattern here in the trinomial gives us two subtraction signs in the factors, and we put a 5 here and a 4 here. Okay, next problem, I'll just go below it here. X here, X here. I've got, well, there's only one set of factors that multiply to be 2, and that's 2 and 1. And if I add 2 and 1, I certainly get 3. And again, we have that same pattern, so we have two minus signs there. Okay, last two. In this example set, I'll go ahead and make both parentheses. This one, x, x. Okay, 5 and 3 do not work because that gives us 8. So 16 can only be gotten by multiplying 15 and 1, or adding 15 and 1. So I'll do 15 and 1 here. Two minus signs. So when I multiply, that gives me a +15, but a -15 here and a -1 here give me -16 for my middle term. Okay, last one of this set, we have a y. I was about to put a y square there, but I'm just ignore that. Y here. 18, 9 and 2 doesn't work, but 6 and 3 do, because 6 plus 3 is 9. So I'm going to put a 6 here, a 3 here, and again, this pattern gives me two minus signs, or two subtraction signs in my binomial factors. Okay, so in this set, all of these had this different sum, or they had this subtraction addition pattern right here. And when you have that, both your binomials will have a subtraction sign inside. Okay? That takes care of example 2. In example set 3, we're going to factor trinomials in which only the constant term is negative. Okay? It's going to work a little different than the last two example sets. So since we're doing these two, I'll go ahead and put both parentheses here. Then we'll talk about what we have to do. Okay? Now, this pattern is going to yield basically a positive and a negative, or an addition sign and a subtraction sign. Not necessarily in any order, because it all depends on where you put your numbers. But we don't really know. We can't. You don't really go in here and just put plus and minus or plus. You just gotta wait and see how the numbers work. So when it's this pattern, what we're going to do, again, we're going to do x and x. That's always a given here for these. Now, what I have to do with this number, I still want to look at numbers that multiply to be 15. And let's write them down. 15 and 1 and 5 and 3, okay? But instead of adding to be 2, they need to subtract to be 2. The difference needs to be 2. So 15 and 1 do not work here, but 5 and 3 do. So I will put a 5 and a 3. Now, it does matter where the plus and the minus go, or the addition sign and the subtraction sign. Because this is a positive 2x, not a negative, the largest number here will have to have the addition sign in front of it. Will have to be positive. So it will be plus and minus. And again, it all depends where that 5 went. It could be minus plus, depending if you would have had the 3 here and the 5 here. So that's what we have to look at with these. When we don't have the first two patterns, we're going to have alternating signs. And we got to figure out what numbers to use and where they go and things like that. So let's look at this one. We're going to use y and y. Now, let's look at multiples of 36. Obviously, or not multiples, but factors of 36. 1 and 36 it's not going to help me because that's a 9, okay? I need to look at things that are a little closer together. Okay, well, 6 and 6 does not help. But what about 12 and 3? Yes, that works. 12 and 3 subtract to be 9. The difference in 12 and 3 is 9. So I'm going to use 12 and 3. Okay, and I notice this term is positive, so the bigger, the larger numeral has to be positive. So it's going to be plus 12 and minus 3. And you can always check your answer by multiplying first, outside, inside, last, and you will get that trinomial when you do that. Okay, let's clear this and go to the last two here. Parentheses, I'm getting, no, I was going to say I was getting better at my parentheses, but my handwriting is still pretty bad. Okay, we're doing this one. Let's look at x and x. Okay, let's kind of look at 40 here. The numbers that multiply to be 40 need to be kind of close together. Okay, obviously 4 times 10, but that's a difference of 6. That's not going to help. What about 5 and 8? Well, that is a difference of 3, and that indeed helps. Okay, so we've got x and x, 5 and 8. Okay, now it's a positive 3, so the largest number needs to be positive. So we put a plus sign there, minus sign there, and everything works out. Okay, let's look at this. We've got z here and z here. 30. Well, the difference between the two numbers that multiply to be 30 must be a 1. So I'm pretty sure it's going to be 5 and 6. The difference between those two is 1. 6 here, 5 here. The biggest number needs to be positive because that middle term is positive, so it's plus and minus. Okay, and just to show you before we finish here, we're going to multiply this out. We get z squared. We get negative 5z. We get plus 6z. And we get negative 30. Okay, and if we put those two together, we get z squared plus 1z minus 30. That, ladies and gentlemen, is example set 3. With example set 4, we're looking at trinomials in which both the middle term and the last term are negative. And that's not going to be there's not going to be a whole lot of difference between this set and the last set we did. Not much at all. Okay, kind of the same thought process. So I'm going to do these first two. I'll just put both sets of parentheses, and I'm still struggling with parentheses. You know, they're hard to do. It's kind of this little curve thing. But anyway, so I've got here a z and a z. And with two negatives here, two subtraction signs, you are going to have a plus and a minus. It's going to be alternating again, okay, just like the last set. So it's pretty much the same thing. What we're going to do is we're going to look at 21, And we're going to look at multiples of 21. That's just 21 and 1 and 7 and 3. Which one of these two numbers, sets of numbers subtract to be 4? And it's 7 and 3. So I'm going to go with 7 here and 3 here. But in this case, and in all of these cases, the middle term is negative. So the larger number needs to be negative and the smaller number needs to be positive. Okay, that's it. That's the only change between the last set and this set. Here we've got 35. 7 and 5 work really well because I know the difference in 7 and 5 is 2. So I'm going to put an x here and an x here, a 7 here and a 5 here. I know they're alternating signs. Two subtraction signs give me that. But it's a negative. The middle term's negative, so the largest number has to be negative. The smallest number needs to be positive. Next two. Let me try a little. Yeah, there we go. That was a good one. If I could keep it up. Maybe not. That wasn't bad. Okay, it's pretty bad when you're really proud of a parentheses. Okay, so we've got y and y here. We've got 72. The difference of the two factors that multiply to 72 to be 72 needs to be 1. And that gives me 9 and 8. Okay, that's the only choice I have because 9 minus 8 is 1. So I'm going to use 9 and 8. The middle term is negative, so the biggest number has to be negative. Okay, those are my binomial factors of that trinomial. Let's do this trinomial. Got a z here and a z here. I'm looking at 28, and the factors that multiply to be 28 must have a difference of 3. That's going to give me 7 and 4. Okay, so 7 here, 4 here. We've got a alternating signs, but that's negative, so negative and plus, or subtraction and addition. Last one. This looks familiar. We've probably done this one before, maybe in the last set, but I've got a z here, a z here, and the factors that multiply to be 20 must have a difference of 1. Well, that's obviously 5 and 4. Put a 5 there, a 4 there. This is negative, so the biggest one must be negative, and that's positive. Or, yeah, that's positive. And that takes care of example set 4. For this last set of examples, example 5 set, we're going to be factoring trinomials with 2 variables. It's not any harder than what we've already accomplished here. We're going to start out again with our parentheses. So I'm going to do the first 2. And again, I see x squared, x, and x. Okay. Now, because this last term is negative, what I need to do is find factors of 55 that subtract to be 6. And that's definitely going to be 11 and 5. Okay? So we got 11 there, and I did not give myself room for that y. Put a little closer. 11 there and a 5 there. And because I have a y squared for the last term, I need to put the y there and the y there with that. That takes care of the y. And it's just going to be a plus 11 because that term's positive, and a negative 5 there. Okay? Go to this one. We've got an m, and I'm going to go ahead and put the ends there because I know I'm going to need the ends. That'll give me enough room. 27, that's 9 and 3. The last term is negative, so these have to subtract to be 6, and they do. So put a 9 there and a 3 there. That's a positive 6m, so 9 has to be positive. The 3 has to be negative. Okay, last 2. Let's go ahead and do these parentheses. Okay, we got A. I'm going to go ahead and put the B there. We got A and B. Okay, they're both plus. That's great. Put a plus sign there, plus sign there. Factors of 32 that add to be 12. Because this is a plus sign, we're looking at the factors adding to be that number. Okay, so that's going to be 8 and 4. 8 and 4 give me 32 when I multiply, and 12 when I add, so 8 and 4. That one's done. See, these are not any more difficult than what we've already worked. Okay, we got a y here, a y here, a z here, a z here. Okay, 28. Well, I think of 7 and 4 when I do 28, and because that's negative, they have to subtract to be 3, which they do. So 7 there, 4 there, or 4 there and 7 there. But I notice that's negative, so this larger term has to be, and I was about to put a positive there, a plus sign. That's negative. That's plus. Okay, that takes care of factoring simple trinomials.